to thank HGS for allowing me to make my presentation. Let's see. Oop, going the wrong way. Okay, why am I here? I'm a geologist like many of you. I'm not a climate scientist, but I've been intrigued by climate, and the main thing that I was wondering about is, as a geologist in the petroleum business, I rely a lot on other professionals. Like a paleontologist, I'll go to a paleontologist and ask about time or what water depth a particular sediment was in, or I'll go to a geophysicist and I essentially rely on their expertise. So I was kind of wondering why a lot of my cohorts and societies like, well, folks in HGS and folks in AAPG were sort of discounting what the vast majority of professionals in the climate science were telling them. Okay, so, and again, I couldn't argue the climate science because I'm not a climate scientist. It could be psychological reasons why people were ignoring this, what the climate scientists were saying, but I'm not a psychologist either. And I'm not an economist, but I can add, subtract, and divide and multiply, at least most of the time. So I decided to investigate possibly if there was economic reasons. And of course there is economic reasons for maybe wanting to avoid this problem. So I wrote this paper, I did the analysis, and I thought the results were interesting, so I submitted it to the Environmental Geosciences Journal of AAPG. And again, an examination of the carbon budget, carbon taxes, industry attitudes to global warming and AAPG. Because if you don't know, AAPG had a climate committee, I think they established it in about 2006, 2007. They sunsetted it in 2010. And essentially it says, we need to research this, but, we're not going to go there because we see no economic reasons for doing that. But I think with all the things that are going on and what I'll present in this talk, I think there is reasons for doing that for all of us to consider it. At least not put our heads in the sand. Okay, the first part of this talk is going to be based on that paper. In the second part, I'm going to be discussing some possible implications if we do something about it, as like putting in a carbon tax or something. Okay, a lot of my skeptic friends say, well, consensus science, so who cares if 97% of climate scientists think, the climate is being controlled by human activity. It doesn't, that is not the way science should be based. And that's not the way this talk is based either. It doesn't matter if the Chronicle says it's happening, it doesn't matter if the Pope says it's happening, or Shell, Total, and ExxonMobil thinks it's happening. Now I did notice when API last week came out in their annual report and said, few things threaten Americans' future prosperity more than climate change. I did notice that, since API is supposedly one of the bigger lobbying groups for the petroleum industry. And then I really took note when James Inhofe, who wrote a book called Climate, the Greatest Hoax, or The Greatest Hoax, signed up with 97 other Senate members to say that yes, the climate is changing. So now he didn't vote to say that human was causing it, but he did say that climate is now changing. But that doesn't matter. What is a fact, whether climate's changing or not, is that there will be regulations constricting our emissions. Now what are those regulations or agreements, I should say agreements? One is the Copenhagen Accord. Now I think we're up to 190 countries, and Barry mentioned about the 2 degrees Celsius. They've agreed that they do not want to go above 2 degrees Celsius, and that they will, which is 3.6 degrees Fahrenheit, they do not want that, the global temperature to go over that. Now what's going to be happening, and they've been meeting, trying to figure out what they're going to do. At the end of this year in Paris, they're going to come up with some levels of CO2 emissions that they're going to be held to, so that sometime between now and the end of 2049, so that the temperature doesn't go above 2 degrees Celsius. And Barry has gone through all the nasty things that will happen. A lot of folks say that it's going to be bad, especially if you're on like the Maldives or something, you're on Guam, you might not really want it to go up to 2 degrees Celsius, but that's what everybody agreed on, and that's the facts. This is what we're going to have to stick with. And it's not really a good idea to ignore the fact, the government saying something like this. Okay, another thing I want to point out to the environmental folks in the crowd is that renewables are going to be the answer, but they're not going to be the short-term answer. Now what we're seeing here, and I think I have the pointer somewhere, but the green is oil, and the red is natural gas, and this is going from 1987 all the way up to 2012. So you can see oil's going up, natural gas is going up. This is coal up here. That yellow is nuclear power. This is hydroelectricity. Now this little thin orange line, that's renewables. Now we're not going to go from renewables here and completely replace this overnight. It's going to be decades. So we're going to have to come up with a transition plan. It's probably going to be, we're going to hope it's going to be 2 decades, but it's going to take decades. We're going to have to work this out. Okay, what are those CO2 emissions going to be? I told you they're meeting in Paris. When I was putting this paper together, I don't know, I didn't have the answer yet because I didn't want to wait until 2015 for the co-op, the group of countries to come up with emissions. So I started looking in the literature. Now Bill McGivens, he's the founder of 350.org. He has this number here, this 565. I didn't just want to use this number. But he mentioned that there was this most influential climate science paper that nobody's read. So I decided to read it. He also says do the numbers. So I decided I would do the numbers. So this is a paper, Greenhouse Gas Emission Targets for Limiting Global Warming to 2 degrees Celsius. I thought this was a good thing to read. It's a good thing to read. It's very interesting. It was written by a bunch of Germans, and they might have written it in German and retranslated it to English, but it is an interesting paper. This is the major chart that sort of summarizes what they found. Now what we have here, these are curves that have been put together from 18 models, climate-based models, fairly conservative climate models. This black line here is the average of the mean of the 18 models. What we're seeing here is the amount of carbon, and these are reserves. So this would be proven reserves. This is total carbon, so it's in the ground. That could be burned between, well, to now till forever, but we need to make agreements to only burn so much between 2000 in the past and 2050. So we have the numbers here, the amount of carbon, and this is total, this is coal, this is oil, this is gas, this is land use. I really didn't go into that. I'm just worried about the fossil fuels. This is stuff that was put in before 2000 till 2006. The analysis was done for this paper in 2006, took 3 years to publish. So it was published in 2009. So these curves, so this is, see how it works. So Bill McGivens said 565 was the amount of gigatons of carbon that could be burned. So looking at this, if you go to 565, which is about the early part of this curve, it's about 15% probability of going over 2 degrees Celsius. So this is a probability curve with 0 probability, 100% probability of going over 2 degrees Celsius. So if we look at, let's say, 1,000 gigatons, go up here, it's about 25% probability. If you burn 1,500 gigatons, stuff that's in the ground, coal, oil, natural gas, then you're up here at about 50%. If I'm pointing correctly, not shaking too much. Okay? So these are probabilities curves. So what I did, and again, I'm looking for a number to look at to see what's going to happen if we put restrictions on oil and gas and coal. What I did was looked at three probabilities, 20%, 33%, and 50%. Now I had to go back and do the numbers. For one, I started in 2012. This paper was written, well, the analysis was started in 2006, okay? So I had to come up with this number here. But also the tables that Meinhausen and Meinhausen et al. Had was just a lump sum. So the total carbon. And I wanted to separate the carbon based on the coal, oil, and gas. So where did I get my numbers? So this was a learning experience for me. It took like over a year to do this, not constant, because I have a job, but on the weekends and at night and things like that. So I found the BP Annual Statistical Review. I don't know, you can download this. They've been doing this for I think 65 years now, because it was part of the government or is part of the government. So this is part of the government service. So they do all the sources of energy, okay? I took all my numbers out of here. I used the conversions from, and I converted everything into millions of BTUs, because you had to convert coal, make coal, natural gas, and so forth compatible. From the Energy Information Administration, I got all my conversions for how much carbon a particular fuel would produce, right? So for instance here, coal, this is pounds per billion BTUs. You get like over 200 pounds from a million BTUs of coal. For natural gas, you only get 117. That's what makes natural gas cleaner. Fuel oil is about 161 pounds per million BTUs. Okay, so this is just one table. I won't go through all these tables, but these are more pretty important numbers. So they have proven reserves. So they have production numbers, they have proven reserves. So this is for oil. So like here, this is in 1,000 million tons proven reserves as of 2012, okay? This is an interesting number. So this is RP factor, so reserves to production ratio. And this was learning to me. I didn't realize this. So what you do is if you look at the reserves and you look at the production rate annually and you divide, you come up with oil 52.9 years of reserves left at the present production rate. For natural gas, it's about 55. For coal, it's about 109. Okay, doing all these numbers and then converting them to CO2 emissions. So what do we have? So this is all of the reserves. So if all the reserves that I got from BP and converted that into carbon dioxide, what are we going to get? Okay, well, for first, the total I came up with was within 100 gigatons of what Meinhausen did. And figuring that Meinhausen et al. Did this 6 years before, I figured 100 gigatons, you know, what's 100 gigatons, right? I wouldn't want it to land at my house, but still, 100 gigatons. So looking at that, coal makes up 66.7% of that carbon. Natural gas, 11%. Crude oil, 15.8%. Tar sands, most of this, well, this is from BP, from Venezuela and Canada, only makes up 6.5%. So, you know, Keystone, it's important, but we're talking about a relatively small amount of carbon. And that's total in the ground now, and most of it hasn't been produced. Okay, so then what did I do? I wanted to compare. So I said, okay, how am I going to do this? Right, I can show the numbers. There's an awful lot more coal. But what I decided to do was, well, how much, if we were to have if the governments were to come back and say, well, we want to go with this 20% probability, you know, we want to use that number as the target. Okay, so this number here, or this little bar here, is how much oil and natural gas we could burn of the reserves, the percentage of the reserves, and this is 0 to 100. How much oil and natural gas we could burn at the same rate that we're continuing to burn coal. So the same rate we're doing now, burning the same amount of percentage of coal, the same amount of natural gas and oil, we could burn 20% 27% of oil and natural gas. Now, we do the hypothetical case where, like if we were in China, and of course China wouldn't do this, but they would say, no more coal. That's the only place they could do something like that. We could burn 49% of our reserves. So, and of course, the more coal or less coal you burn, if you want to go to that limit, it means the more natural gas and oil you can burn. Jumping all the way over to the 50% probability, if you continue to burn the same rate of coal, oil, and gas as we are now, you could still burn 56% of the reserves of oil and natural gas. If you stop burning coal, you could burn all the reserves of oil and natural gas as of 2012. Now, there's two things that are wrong with this. Well, this couldn't happen. But even if you could happen, one thing, would you want to leave the planet with a 50-50 chance of going over 2 degrees Celsius? Probably not. That's like, you know, if a mechanic came up and said, well, your plane's going to have 50-50 chance that's going to run into problems. You really put yourself or your kids on that particular plane? But the other thing is, there'd be a lot of chemists and plastic makers and people that wanted to make solar panels with plastic. They'd be a little ticked off after 2050 if there wasn't any more oil and natural gas feedstock for these products. So, okay. Now let's go. ExxonMobil is now the biggest natural gas producer in the United States. And they figure they stand to profit if a price is placed on carbon emissions, because it's going to make natural gas, their biggest thing that they're doing, a lot more attractive. In fact, Rex Tillerson, the chairman and CEO, favors a carbon tax. So what I'm going to be doing now is I'm going to show you what would a carbon tax do. And this is also from my paper. What we have here, this is in years, going out 20 years. This is cost in millions of BTUs. And what this tax is for every ton, you charge $10, and for each year, you go up another 10. So at the first year, it's $10 per ton of CO2. This is a short ton. I did these in short tons. And after 20 years, it's $200 a ton. So what do we look at here? This is coal. You can see it goes up more rapidly than natural gas. After about 4 years, and this is a very hypothetical chart where the only variable is the carbon tax. And we already know that that is not the only variable. In fact, this number here, oil and tar sands, this is a number from 2012, and actually the start now is half of that, since oil is half the price as it was in 2012. But still, what you can see, after 4 years, natural gas becomes cheaper than coal. After about, and I can't get this angle here, but after 10 years or so, coal is more expensive than geothermal. Now, all renewables, they have a flat line because they're not emitting any coal, so they don't have a tax. Now, the reason why these things are so expensive is I'm using the levelized cost of energy. These numbers are from the EIA. They factor in the 30-year cost of the factories and all the power lines and things like that. So that's, it doesn't cost very much to get a solar panel once the solar panel's up on your roof, but you got to put it up on the roof. Okay. So this is interesting. Even after, so you can see better here, after about 18 years, only then does coal become more expensive than onshore wind. Okay. So coal is still viable. Natural gas stays cheaper than onshore wind even after 20 years. Now I have oil in here, even though it's a different kind of fuel, as you know. It's a transportation fuel. But if you're getting power from a windmill, maybe to power your Tesla, it becomes cheaper after about 5 years. But actually, this is at the 2012 price, so you got to take it out more now. Hopefully that the price of oil won't be staying the same. But I think you get the point how this thing works. Okay, so that was mostly what I had in my paper. And if you want to copy my paper, I can give you an abstract as my email and I can send it to you. But now we're going to go into what other people have been talking about, mostly economic implications to the country if you have a carbon tax. And I think you'll find it interesting and not what you expect. Okay, first, before I go into that, what are the economic implications if we don't do anything? And this is from a book called The Climate Casino, a fellow by the name of William Nordhaus, who's been doing economic and climate issues for decades. He's at, I think it's Princeton. Okay, so he has this curve here. This is temperature going from global mean temperature from 0 to 5 degrees increase. And this is damage in percentage from 0 to 6%. So a 6% decrease in, let's say, the global production. So as the temperature goes up, the economy goes down for the same reason that Barry was talking about. Okay. This is not a talk about, you know, comparing cap and trade or other factors. This is going to be, I'm just going to talk about the simplest one that I could find, and this is a carbon fee and dividend or revenue neutral climate tax. For one, I have a report showing what the effects would be on the economy. Now, what is a carbon fee and dividend? This is James Hansen. He's for this. What it is 100% of the money or fees that are taken from the well or the mine and is added to the price of the fuel. Essentially, it is a fee that's taxed from the company that's producing this stuff, and it's distributed uniformly to families. Okay, probably by the IRS, but 100% is distributed out to people. So. One group that is promoting this, and for, let's see, full disclosure, I'm a member of this group also. It's called Citizens Climate Lobby. This is not, even though I advocate this, this is not just for, I'm not just advocating this. This has been, for the last couple of years, people have been talking to your congressman and your senator about this. And this report I'm going to be just highlighting has been given to all the congressmen and all the senators. It was briefed to standing room only crowds in Congress this last June. So if you don't like what you see, you can go talk to them about it. But this is a report that was commissioned partly by the Citizens Climate Lobby by a group named REMI, which is Regional Economic Modeling, Inc. And this is not like a Greenpeace outfit. They're an economic outfit. They've done stuff for the Connecticut Light and Power, Massachusetts Division of Energy Resources, Tennessee Valley Authority. They do economics. So I think you'll be surprised. The Citizens Climate Lobby was very surprised at what they saw. Some of it is good news, some of it is bad news. What we're seeing here is this is employment. This is going out over a 20-year period. Now remember, you're taking $10, you're adding it to each ton of carbon, and it goes up over 20 years to $200. And this is employment in all the regions, and here are the different regions. So these are regional changes in employment. All the regions go up except for one. This is the regional economic growth. Most of them go up, and again, this was not anticipated. But you kind of figure, you know, you give back people a bunch of money, and you know they'll go spend it. Now, what this is supposed to do, now people can go buy their energy from coal, but it's going to become more expensive. They're going to be able to buy energy from tar sands, but because there's more carbon tax on it, the price is going to go up. So this is supposed to drive people and companies to consume energy with lower amounts of carbon. Now the bad news is there's one particular region that doesn't do very well, okay? And guess what region that is, right? So it's light blue, and there's a light blue one. Oh yes, that's Texas, Oklahoma, Arkansas, and Louisiana. Mississippi and Alabama don't do that badly, but still they're not doing great. But the baseline here is zero. So this is zero economic growth taken out over 20 years. If you make the baseline 2.5, now the growth over last year was 2.4, actually we still stay above positive. So here we're actually between +5 and +1 growth. So there still would be growth It just wouldn't be as fast as the rest of the nation. Now let's throw that curve, and I had to warp it to make to the same scale. So it's the same scale as the Nordhaus curve. And actually, 20 years out, I was able to match it by looking at the NASA and the NOAA curves of what to expect, what the temperature is supposed to be in 20 years. And I might still be alive when we're out here. I'm 68, so maybe not, but. So we're going to get it either way. If we ignore it, the situation, the economy is going to go down. And I think we're seeing when we have a worldwide recession and slowing in China, it decreases the demand for oil and gas. So we're hurt that way too. If we have a 2% growth, like I showed the other chart, we'd bounce this up here and we'd be in positive growth, we'd be above zero. So what do we want to do? We just want to hold our heads in the sand and just hope that nothing happens, which, you know, that's up to you. All right, is there any chance of a carbon tax actually being implemented? Well, when I was doing research, I found this report, and I think it's Carbon Disclosure Project, and they mentioned that, 26 major companies working in the United States are planning on a carbon tax in the future. One of those is ExxonMobil. These are lists of the energy companies, 9. Now, I think they're not just doing this because of, Copenhagen and Paris. I think they also might be thinking because their scientists are telling, well, I think maybe this climate change thing is really happening. We maybe better do something. In fact, in the table in the bulletin and the table in the paper list all those statements from these various oil companies, and it varies. But when I was doing this, these are sort of mainstream companies. I decided, well, let's go to the real end member. Let's see what the Koch brothers are doing, right? So this is the boogeyman of the environmentalists. Well, I looked at I didn't go back into the history, but I went to the website of the Americans for Prosperity. And what is the big thing they're pushing now? It's a no climate tax pledge, okay? No climate tax pledge. Well, some of our locals, John Culberson, Pete Olson, Joe Barton, Ted Cruz signed this. Well, it says it's a no climate tax, but what does it say? It says, I, the undersigned, pledge to the American people that I will oppose any legislation relating to climate change that includes a net increase in government revenue. When I told James Hansen by email, I haven't talked to him, that he had the same position of American Prosperity, he said, well, I can't wait till I get an invitation to speak in front of him. That I don't think has happened yet. But why haven't the Koch brothers, why don't they say, well, sign a pledge that the climate isn't changing, humans aren't doing it? No, maybe they read some of their science reports that they fund. And the Koch brothers do fund science, and there was a very interesting report which I won't go into, but I'll leave it up to you as to why they're pushing this. Now this is the last chart. This is also from that Remy report. What if we cleaned up the air, and there was no climate change? Gee, that would be a terrible thing. This is the number of lives saved in thousands, and this is one curve where our region actually improves with everybody else. So there'd be thousands of lives annually saved over this period of time if we cleaned up the air. And what if we don't do anything? Okay, Barry showed you that. Do you want to leave this for our children and our grandchildren? And no, this is not my grandchild, but I couldn't get my son to stand in the woods with a sign saying, there's no planet B. So I just got this young lady off the internet. But she's pretty cute, isn't she? And there is no planet B. So what gets me, we solve so many problems in our industry right now. We had peak oil, now we don't have peak oil, now we have sort of expensive oil, which the Saudis are taking advantage of. But we solve problems all the time. Why don't we just consider this another problem that we have to solve and not ignore it? Let's just go ahead and solve it. And well, with that, thank you.
Open up the floor to questions. Anybody want to ask some questions?
And that there's going to be some negative impacts. And there's going to be some benefits as well, but overall it's going to be a net negative for the planet. You're correct. Cold is not good for crops, but it's not getting colder, it's getting warmer.
Well, okay, I will contradict you there. This is a chart from Hadcrut with Hadley and Climate Research Group out of England for the last 17 to 18 years, and it shows slight cooling. These are the global warming people.
That 17 years is not a climate. 30 years is a climate. And if you look at my decades, you saw that the climate is still warming. And if you can go back 50 years and see a 10-year period where the climate is not warming. That is 100% consistent with everything I said. You're also only looking at the air temperature. You're not looking at the ocean heat.
No,
and I clearly showed that the ocean heat is 90% of the warming.
That's not true, and I just confirmed it on the internet. This is based
everything
on
not everything you read on the internet is fact.
This is their website.
Not every website is fact.
Their website.
I'm saying that data is correct, but that's not what climate is. Climate is not 17 years of data. And in fact, the Earth is warming up over the last 17 years, and if you look at the ocean, it's very clear.
We're going to have to cut it off for a minute and let other people ask questions.
We had a little ice age. Do you agree with that?
I talked about it.
All right. Earth's been warming for 300 years. CO2 level did not start up until the Industrial Revolution, where we could start measuring the increase in CO2.
Oh, we can measure the increase in CO2 going back 800,000 years, right?
Up and down and up and down.
Correct.
And up and down and up and down.
Correct. And that was due, and CO2 is not the only way to change climate. The way you change climate is changing the amount of the energy budget, the energy coming in versus the energy coming out. Some of the climate change is due to changes in the strength of the sun. I clearly said the ice ages were caused by changes in the Earth's tilt, changes in the Earth's orbit, not CO2
Although I'd like to interject
But
something.
my point is,
Just one
why
second.
are you blaming the first 150 years of warming on natural causes, and yet you're going to blame the last 150 years on carbon dioxide?
Let me go back to my figure, if you may.
At
the last 100 years of warming.
It's been warming since the end of the little ice age.
If we go right here, right? This is still a cooling trend, and then this is the warming.
You're looking at a completely different curve than I am, that's come from a bunch of NASA people.
I am a NASA scientist. I get funding from NASA to do my research. Here's another going back 5.5 million years. You can clearly see a gradual cooling for the last 5.5 million years.
Okay.
So, Barry, can I make a comment? I think the pointer's over here.
I have it in my pocket.
Some of these things are related to the Milankovitch cycle, right?
All of this is the Milankovitch cycle. This is
Are you familiar
41,000
with the
years.
Milankovitch cycle? Yes, sir. Now, correct me if I'm wrong, but according to the Milankovitch cycle, we should be getting cooler. Is that correct?
About 3 years ago, we turned cold.
The very gradually, slowly cooler, according to Milankovitch cycles. But there's other changes that have happened. The sun has gotten a little brighter over the last 100 years. That's why I said the natural causes are about 0 over the last 100. 100 years is a very short time geologically.
We're aware.
I know. That's why this should not be a shock to you guys.
Well, what you're replacing is, you've been following the news that we've been getting some of our, on certain peak days, we've been getting 40% of our energy in Texas from wind power.
I heard that as well.
Yeah, that has occurred.
That's from ERCOT. ERCOT reported. That's a very extreme case.
Right.
But on a very windy day in the summer, we got a couple times, we got 40.
Well, I mentioned that the Koch brothers, and I had a slide from the front paper. Richard Mueller, who is a Berkeley environmental atmospheric scientist, he wrote a op-ed for the Wall Street Journal, which is one of those liberal rags that comes out of New York. Essentially said that if you were skeptical about climate change, you have good reason, but now you don't. And essentially, it was a partly Koch brothers funded study where they went back and looked at historical records since I think the 1700s. And the main driver, they looked at volcanics, they looked at sunspots. The main driver was CO2 emissions from burning carbon. And that's the Koch brothers funded study.
I'm going to ask this guy back here because I don't know him. Everybody else I do.
So there's no silver bullet. There's not one thing we can do. Planting trees is helpful. It's certainly better than cutting them down. The trees don't live very long, and when they die, that CO2 goes back to the atmosphere, so it's not a long-term solution, but it helps on the short term. I think oil companies know very well how to put CO2 into the ground, and I think if you can do it in an unpopulated region, it's a very good thing to do. It turns out NRG is going to take the Parish Power Plant in Sugar Land, one of the boilers, and devote it to capturing the CO2, building a pipeline with the Japanese and putting it into an old oil well about 80 miles away. I don't know why they're doing it because there's not a price on carbon yet, but it's going to cost them about $1 billion, and they're moving forward with that project.
Having been on a sequestration project and talked to other people, I'm not sure it's really a cost-effective way of getting rid of the CO2, except maybe like the Bureau of Economic Geology. They're looking at studies about putting it into some of the offshore wells in state waters, so they can get a royalty for this, and they can also get more production. But and then as far as the trees, when we were doing the CO2 sequestration, we had to guarantee that the CO2 would stay in the ground for 1,000 years. And I don't know of any trees that hang around for 1,000 years.
I'm a huge fan of nuclear power.
That's great.
Yeah.
There's a whole bunch of people out there that were afraid to say it. And
Well, it's California, so.
Well, the Germans are scared of nuclear power and the Japanese, but...
Yeah. Germans were not going to be hit by a tsunami.
The French generate over 80% of their electricity from nuclear power.
They recently said they're going to back off.
Well, if I could add just a comment here. James Hansen, who I mentioned here a number of times, probably know the name, he's a big proponent for nuclear power. But one of the things about this carbon tax, it doesn't, and also James Hansen was a federal employee for many years, he doesn't want the federal government to get the money and make the decision. He wants, that's why he's for this revenue neutral carbon tax, or carbon fee and dividend. He wants the American people to choose what they want to, spend their money on for energy. And if they decide it's going to be nuclear, it's going to be nuclear, or if it's going to be wind and solar, but they're going to drive it.
In the south, so do you have a comment on that?
They're shrinking globally. I've been to Antarctica and to Greenland. NASA has these wonderful satellites that are radar, and they're measuring. They get a radar signal from the top of the ice, and they get another one from the bedrock underneath. And so we have great data for the last 30 years of the melting of the polar ice caps, both Antarctica and in Greenland. It turns out that as the air warms up, warm air holds more water. So you're going to get more snow in the center of the ice sheets, because right now it's so cold, there's not much water that can fall. The air doesn't hold much water. So you will get more snow in the middle of the ice cap, but the edges are melting faster than the middle is getting more snow. So you're hearing...
diagnostic of climate change?
That's completely consistent with the idea that greenhouse gases are causing the warming. If the sun was getting brighter, the stratosphere would not be getting colder. The stratosphere is where the ozone layer is, and there'd be more UV and there'd be more warming of the stratosphere. But because the Earth's surface is getting warmer and the stratosphere is getting colder, it's more evidence that it's the greenhouse gases that are causing the warming, not the not any potential brightening of the
Give
sun.
Clint the last one, because it's getting past 8:30. I always try to get everything wrapped up by 8:30. We can always hang around afterwards.
Yeah, I'm happy to stay. Linzin has retired, and his ideas haven't changed in 30 years, and he's completely discredited in the climate science community. No, it's not me. What was the last paper he published in a peer-reviewed journal?
All right, let me continue. As far as water vapor, I see no acknowledgement of the impacts of water.
It was in my chart here, and I just mentioned how water vapor would cause more snow. But if we talk about the indicators, I only had 20 minutes.
I understand.
And
40, because I would have gained a lot more from 40 for years.
you warm up the air, and water vapor increases. So, all right, I'm happy to tell you about clouds having both a negative and a positive feedback. And the net effect is about, it turns out the net effect of clouds is warming because at night, and here, again, nighttime temperatures are warming up faster than daytime temperatures. Clouds are made of water. Water's a greenhouse gas. It's actually the most important greenhouse gas. Why are we talking about CO2 and not water? Water stays in the atmosphere for 10 days. CO2 stays in the atmosphere for 20 years, okay? That's why we could have a machine that pumped water in the atmosphere. You shut off the machine, 10 days later, all the water's back on the ground. That's why we talk about CO2. Why is there more water vapor in the atmosphere? Because there's more CO2 in the atmosphere. CO2 is warming the atmosphere, and then more water evaporates, and warmer air holds more water, and so there's more water in the atmosphere.
So with flares...
No, of course, I didn't get a chance to talk about the sun. But the sun did have an extended down period in 2011 and 2012. Now it's on its way back up again. And the changes in the total, that 238 watts per meter squared between a down cycle and an up cycle is less than 1%. And the sun 4.6 billion years ago was 27% dimmer. There was a faint early sun, and it's gotten brighter over the past 4.6 billion years. But there was a lot more CO2 in the atmosphere, in the Earth's early atmosphere, which is why we've always had liquid water on this planet. The sun has been very extremely well measured over the last 40 years, and the sun is not the cause of the recent warming. The sun does not explain the last 50 years of warming.
And we can take this up afterwards, but I'm going to give you the last statement, James. I'll let you last.
The first part of my talk was based on a paper that I wrote and was peer-reviewed. If you have certain comments and theories, I suggest you write a paper, submit it for review. Regarding the other part, I was afraid about advocacy, but the revenue neutral climate tax is the easiest one to look at, and I thought the economic report, which again was submitted to your congressmen and your senators, you might want to know about it, gave some interesting economic responses that are kind of surprising. Because I don't even think the Citizen Climate Lobby thought that the economy could actually improve with a revenue neutral climate tax. So if you didn't like to hear that, you know, I was the speaker. So, thank you.
Well, guys, I appreciate you coming. I've got these awards for you. Please don't throw them at me.
No, thank you so much.